Section 9-4, congruent figures. A two-dimensional figure is congruent to another two-dimensional figure if you can map one figure to the other by a sequence of rotations, reflections, and translations. This symbol that I'm going to draw for us, means is congruent to. So in this figure, we have two congruent triangles. We have triangle ABC, and it is congruent to triangle A prime, B prime, C prime. And if you can map one figure to the other by a sequence of rotations, reflections, and translations, then the triangles are congruent. All right? So you see that these triangles have either been rotated, reflected, or translated and formed the other one. Therefore, triangle ABC is congruent to triangle A prime, B prime, C prime. All right. Now, it actually looks to me like this triangle was reflected and then translated. Okay, think about that. This triangle was reflected over and then translated. Okay, now let's look at part 1. Describing sequences of translations. This time we're going to determine, was this triangle reflected? Was it translated? If it was translated, how many to the left, how many to the right, how many up, how many down, okay? So you are given that triangle ABC is congruent to triangle A prime, B prime, C prime. Describe a sequence of rigid motion that maps triangle ABC to triangle A prime, B prime, C prime. So let's just take a look. I'm going to place my little triangle over ABC. Okay. If I can see here that A is at the top and A is still at the top here. B is still to the left of A. B prime is still to the left of A, bottom left of A. Okay? So if you notice, these triangles are still in the same direction. So it looks like to me it was just translated. Maybe we could say to the right so many units and down. Okay, because think about it. This triangle has been moved to the right and then down. All right. So here we have a triangle. So let's look at A. How many units will we have to move A to the right? And how many units will we have to move A down to get to A prime? So let's start counting. 1, counting over my boxes. 1, 2, 3, 4, 5. So we went 5 to the right. Now let's come down. 1, 2, 3, 4, 5, 6 down. So if I move A to the right 5 and down 6, I'm at A prime. Let's see if that same pattern works for the other vertices of the triangle. Vertices are your points on the triangle where the two segments touch. A is a vertices, B is a vertices, and C is a vertices. Okay, so let's move C to the right 5. 1, 2, 3, 4, 5. So yes, that's correct. And down 6. 1, 2, 3, 4, 5, 6. So we had to go. C does match up with the pattern as well. So now let's try B. To the right 5. 1, 2, 3, 4, 5. And down 6. 1, 2, 3, 4, 5, 6. So yes, we've got 5 to the right and 6 down. So as you can definitely see, this triangle was moved to the right 5. 1, 2, 3, 4, 5. And down 6. 1, 2, 3, 4, 5, 6. And it fits perfectly on A prime, B prime, C prime. So therefore, we can say a single translation of 5 units to the right and 6 units down. Maps triangle ABC to triangle A prime, B prime, C prime. So a single translation of 5 units to the right and 6 units down maps triangle ABC to triangle A prime, B prime, C prime.